All right, so now we have got in better situation to understand how to calculate the probability. And I know that most of the people have tried understanding probability, and trust me guys, very few people understand the logic of it, and the process is fairly simple. Now the idea over here is that how to calculate the probability, and if you understand this logic clearly, it will be piece of cake for you to understand or to calculate the probability, right? So what we want to do is we wanted to understand what is this probability like. Okay, so let's understand, right? So we just wanted to measure how often something is happening. Now how often is a pretty I would say term which needs to be described clearly, but how often is can be calculated as relative frequency. So say if I wanted to give you some idea about how often, say for example, if I toss the coin, okay, let me just pick up this over here. Say if I have a coin, right, and I wanted to get head or tails in that coin, and if I toss this coin total number of times, say 100 times, okay, now if you toss this coin 100 times, right, what are the probability, right? So you may get say 66 times, and it's a fair coin, right? I would say fair coin, right? Fair coin means that probability of me getting head and tail, right, are equal, right? It's a fair coin. We'll talk about that, what for a fair coin is, right? And what is that means that if I toss in ideal situations, if I toss the coin 50 times, I'm supposed to get head, and 50 times I'm supposed to get tail, right? I'll just talk about, and this logic is very crucial for you to understand, because this is the point where people get fail most of the time. So say in a random experiment, I did one experiment where I tossed the coin 100 times and I guess 66 times I got say heads, or maybe I'll just take it for the simple calculations. I'll just simply say 60%, 60 times you got head and 40 times you get tail, which is pretty much possible, right? So I would say a relative frequency, right? Relative frequency of me getting say tail would be equal to number of times I got tail divided by total number of experiment which has happened, right? So I would write over here frequency of tails divided by 100. Notice that it's a relative frequency, it is not the probability. Okay, so ft would be frequency of tails divided by total number of events we have. So I can safely define it as ft divided by total number of events, where n is the total number of events I have. However, relative frequency is equals to, I can simply say relative frequency of heads would be number of times I get heads divided by total number of events I have got in this experiment. So I will say f of h divided by total number of events, right, which is n. N is always same because total is 100 over here, so this is always remains the same. So relative frequency of head is 0.6 and relative frequency of tail is 0.4. Don't ever get confused between relative frequency and the probability. However, probability is a little different from this idea. Okay, so what is this probability I'm talking about? Let's understand this. Okay, so if my n keeps on getting larger and larger, right, what will happen, right? My sample will become population, and relative frequency will become probability. Now what exactly this idea is, right? So don't get amused by the different ideas over here. So let's say suppose say if I get, so n is 100 right now, and number of times I get head is 60 and number of times I get tail is 40. Okay, so my relative frequency of head is 0.6, okay, and relative frequency of tail is 0.4. Okay, and n is given as 100, right? This is one situation number one. Okay, now let's go to situation number two, right? So situation number two is, right, n is equals to say 100,000. Now what will happen when I have n is equals to 100,000? Okay, so h will not be now 60%, right, of the total event. It will be somewhere around 5,000, or I'll say something of this sort, right? Something of this 2, or tail would be somewhere around 49,998 or something of that sort. Now if you calculate the relative frequency of head over here, it will come out to be 0.50001 or something of that sort. Of relative frequency of tail will become 0.49998 or something of that sort. Okay, something of this sort. So you get almost, and this is equals to what, right? This is equals to 50. This is also equals to 50, right? 0.5. You can simply say this is close to 0.5. Now even if you increase the value of events to infinity, right, this will eventually become 0.5. Relative frequency will become 0.5 and 0.5. Now this relative frequency, when n is infinite, right, is called probability, right? This is called probability over here. So my relative frequency will become probability when my n gets sufficiently larger to an infinite times, right? So if I have a sample, right, we can just define how often it is happening, right? And I can just calculate the relative frequency. But when I have a population, I will be always like picking up the probability over here. For a sample, it will always be a relative frequency. It will never be actual probability. So though the relative frequency of sample of me getting head could be 0.6, and relative frequency of sample me having tail will always be 0.4, but the probability of population, which is always be calculated for a population, for head will always be 0.5 no matter what, and probability of population of tails will again be 0.5 always. Okay, like 50% of the probability. Okay, now the probability varies from 0 to 1. It cannot happen more than that. So 1 is that it is certainly going to happen, right? And 0 is impossible event. So if I have a probability say 0.7 or 0.8, I would say it's a highly likely probability. If I have a probability of 0.1 or 0.2, it is highly unlikely, right? Something happening. So we'll discuss that. We'll use that multiple times so that you can understand that concept over here. I hope you're getting this idea about what I'm talking about, right? So let's deep dive into the basic concept of probability so that we can move next, and we will understand some basic concepts of the probability. Then we'll move towards the higher logic of the probability. I'll see you in the next video.